Hello friends and welcome to the math class by Pratik. In this video session, we are moving further to the differentiation class and we will learn about higher order derivatives which are also known as successive differentiation. Till now we have seen only the first order derivative. For example, if y is equal to fx is a function given to us, then its derivative we know that it is denoted by y dash or f dash x or dy by dx. We are generally using the symbol of d by dx or we are using the symbol of dash to represent the differentiation. Now once we differentiate one time, suppose we are asked to find out differentiation one more time, then this is the case of higher order differentiation, or we can say it is successive differentiation, one differentiation after the other differentiation. So differentiating these functions again with respect to x, we get second order derivatives and they are denoted by, since we are differentiating two times, one time differentiation was y dash, two times differentiation will be denoted by y double dash. One time differentiation was f dash x, two times differentiation will be denoted by f double dash x. One time differentiation of y was dy by dx, two time differentiation will be denoted by d square y by dx square, and so on. To understand this more briefly, we consider the table below. See, this is a function which is given to us, y is equal to f of x. If we differentiate it first time, it is called the first order derivative, d by dx of y, or we can write down dy by dx, or since it is first derivative of y, we can write down y dash. It is also denoted by y1, which is first order derivative of y. Since function is f of x, we can also write down f dash x. All of these are the notations for the first differentiation, which is called the first order derivative. Now if we differentiate this one more time with respect to x, then we get the second order derivatives. This was the first order derivative, and if we are differentiating again with respect to x, it means it is d by dx of dy by dx. This was first derivative, we are differentiating this again with respect to x. So you can see that this is nothing but d square y divided by dx square. Since this is second order derivative, it is denoted by y double dash. If you denote in terms of dash, if you denote in terms of suffix, then it will be y2 because it is second order derivative of y. If you denote in terms of f of x, then it will be f double dash x because it is second order derivative. Now if we differentiate this second order derivative again with respect to x, then we will get third order derivatives. So third order derivative is nothing but, this was second order derivative and we are differentiating again with respect to x. So finally it will be d cube y divided by dx cube, or we can say it is y triple dash, it is denoted by y3, or f triple dash x. So these are notations for higher order derivatives. Generally if we talk about polytechnic math, then you will find out in most of the cases examples up to the second order derivative. If you talk about the degree engineering math, then you may get third or fourth order derivatives also. So now let's proceed for the examples related to this. The first example is y is equal to 5 into e raised to 3x plus 4 into e raised to 2x. Then prove that d square y by dx square minus 5 dy by dx plus 6y is equal to 0. We have to prove this. So here you can see that to prove this, we will need d square y by dx square and we will need dy by dx. Y is already given to us, so we need not to worry about this, but we need to find out first order derivative and second order derivative. So we have y is equal to 5 e raised to 3x plus 4 e raised to 2x. Differentiating with respect to x, we get dy by dx is equal to d by dx of this. So dy by dx, 5 is constant, we can take it outside, and d by dx of e raised to 3x plus 4 is constant, it can be taken outside, d by dx of e raised to 2x. Now here, to find out the differentiation, we need to apply the chain rule. We know that two functions are, if e raised to x is given, then there is no requirement of chain rule, but here it is not simply e raised to x, but it is e raised to 3x. So we need to apply chain rule. First, there will be the differentiation of exponential function, and then there will be the differentiation of 3x. We know that derivative of e raised to x is e raised to x. So 5 as it is, differentiation of e raised to 3x is e raised to 3x into differentiation of 3x is equal to 3. In the same way, 4 as it is, differentiation of e raised to 2x is e raised to 2x into differentiation of 2x is equal to 2. So simplifying this, we can get this 5 into 3 is equal to 15 e raised to 3x plus 4 into 2, 8 e raised to 2x. Let's say this is equation number 1, because we have reached to the one of the milestone. We have calculated dy by dx. Still we have to find out d square y by dx square. So we have dy by dx is equal to 15 e raised to 3x plus 8 e raised to 2x. We will differentiate this one more time with respect to x. So the differentiation of left hand side will be d by dx of dy by dx, and differentiation of right hand side d by dx of 15 e raised to 3x plus 8 e raised to 2x. So this is nothing but d square y by dx square. And here we can separate the terms, 15 outside, d by dx of e raised to 3x plus 8 outside, d by dx of e raised to 2x. To find out these derivatives, again we shall apply the chain rule. So 15 as it is, e raised to 3x into 3 plus 8 as it is, e raised to 2x into 2. And simplifying this, we get 15 into 3 is equal to 45. So 45 e raised to 3x plus 8 into 2 is equal to 16 e raised to 2x. Say this is equation number 2. So we have reached to our second milestone also. Now finally we will substitute values of y, which is given here, value of dy by dx which we have obtained as equation number 1, and value of d square y by dx square that we have obtained as equation number 2 into the left hand side here, to prove that this is equal to 0. So let's note down what are the values of dy by dx and d square y by dx square that we have obtained earlier. Now starting with left hand side is equal to d square y by dx square minus 5 dy by dx plus 6y. Let's substitute these values. So d square y by dx square is equal to 45 e raised to 3x plus 16 e raised to 2x minus 5 as it is, dy by dx is equal to 15 e raised to 3x plus 8 e raised to 2x plus 6 as it is, and y is equal to 5 e raised to 3x plus 4 e raised to 2x. Simplify this. So this is 45 e raised to 3x as it is, this is as it is, this is 15 into 5 is equal to 75, 8 into 5 is equal to 40 which will be negative, 6 into 5 is equal to 30, and 6 into 4 is equal to 24. Here I have denoted them by different colors because you can see that we are having two types of term. One type of term having e raised to 3x, e raised to 3x and e raised to 3x which are indicated in the red font. The other type of terms are e raised to 2x, e raised to 2x and e raised to 2x. They are denoted in blue fonts. So first you can see that this is 45 minus 75 and plus 30. 45 plus 30 is 75 and minus 75. So finally all these red terms will be cancelled out, which are in terms of e raised to 3x. Now consider the blue terms, 16 e raised to 2x plus 24 e raised to 2x, that is 40 e raised to 2x minus 40 e raised to 2x. So again this will also be cancelled. So nothing is left, hence we get 0, which is equal to right hand side. So example is quite lengthy, but the process is very simple. To get more detailed solution, let's see another example. Y is equal to cos mx plus sin mx, then prove that y2 plus m square y is equal to 0. Here we will note down that m is a constant. Further, y2 represents the second order derivative. So we will have to find out y1 as well as y2, because to find out y2, y1 is necessary. Without y1 we cannot find out y2. So y is equal to cos mx plus sin mx. Differentiate with respect to x, we get dy by dx is equal to d by dx of right hand side. Dy by dx is equal to d by dx of cos mx plus sin mx, separating both because plus sign is given, so we can separate derivatives. We know that since cos mx is given, we'll have to apply chain rule here. Whenever except x something else is given, in all the case chain rule will be there. So first we will differentiate with respect to cos, and then we will differentiate mx. Differentiation of cos is minus sign, so minus sin mx into differentiation of mx. Similarly here, applying the chain rule, first differentiation of sin is cos, so cos mx into differentiation of mx. So minus sin mx as it is, m is constant, so it will be outside, and differentiation of x is 1. So finally we left with m. Cos mx is as it is, m is constant, it can be taken outside the differentiation process, and differentiation of x is 1. So here also we left with m. Now from both the terms we can take m common, or let's keep as it is till now. So first step will be minus m sin mx plus m cos mx. This is equation number 1, which is y1. Now we will find out y2. So again differentiate with respect to x. So d by dx of dy by dx is equal to differentiation of minus m sin mx plus differentiation of m cos mx. M is constant, so we are taking it outside. Here also we are taking it outside, and here we will have to apply chain rule. Differentiation of sin is cos, so cos mx into differentiation of mx. M as it is, differentiation of cos is minus sin, so minus sin mx into differentiation of mx. M cos mx, m is outside because it is constant. Differentiation of x is 1, so here we left with only m. Similarly, m is outside, we can take it, m is constant, we can take it outside, and differentiation of x is 1. So this is d square y by dx square, or we can say y2 minus m square of cos mx minus m square of sin mx. You can see that both terms are negative and both are having m square. Say this is equation number 2. So let's note down both what we have obtained, and starting with left hand side, y2 plus m square into y. This is y2. So substitute value of y2 minus m square cos mx minus m square sin mx plus m square as it is into y, which is already given to us, cos mx plus sin mx. Let's separate these terms by multiplying by m square. So first as it is minus m square cos mx minus m square sin mx. This is m square cos mx plus m square sin mx. These two blue terms are related to sine function. Both are opposite to each other and will be cancelled out. Red terms are in terms of cos function. They will also be cancelled out. So we left with 0, which is our target. is equal to right hand side. So this was about higher order derivatives. You need to practice more examples to get command on this topic. So in this lecture we have discussed about successive differentiation, or we can say higher order derivative. Stay tuned for more videos. Thank you.